back, everyone. Today our topic is work done by a swing force. Work done on or by swing. Work done by swing force. Work done by swing force means, so we know dW is equal to F into dx. So that equal to kx into dx. So integrate now we get potential energy means, and here the work done is stored in the form of potential energy, because the spring force is conservative force, and the spring force is always spring force is always sorry spring force is always opposite to opposite to opposite to motion of the black, opposite to motion of black or body. Maximum cases black only written, right? And spring force, the potential energy stored in the spring is equal to half kx square. Here x is compression or extension, and in compression and extension two cases are to study. So in example, maximum extension is how much they're asking, suppose. So in that case of maximum extension, the work done is equal to half kx square will die. So only compression or extension in equilibrium. So in equilibrium, F equal to kx, mg is equal to kx, mg is equal to kx, or F is equal to kx. So this is in equilibrium. The string is suspended by mass, or the mass is placed on the spring. So it is in equilibrium, it's at natural length. So this x is equal to natural length, and it is in equilibrium. But maximum extension, the maximum extension. So the velocity of the block is equal to 0. Velocity of the block is equal to 0. That means the potential energy of kx square is equal to mg into x. When block is coming and falling on the spring or suspended, I will explain those problems under. Then half kx square equal to mgh. Then this is called maximum extension. The x equal to 2mg by k. In many of the cases, 2mg by k. So it is not special, right? Specially not mentioned means that x equal to 2mg by k always. Means of kx square equal to mgx. Therefore, x maximum extension is 2mg by k, except in special cases. So that special cases what we'll discuss later. Now, when two or more springs are connected parallel or series, then effective spin constant or effective potential energy is how much? How much energy is stored in these cases? To find that, first let's consider two springs of different spin constant K1 and K2. So M is suspended. So if these two springs are like this also, this is also called as spin parallel connection only. So in parallel connection, the displacement of the block is same. If they have, even though they have different coefficients, that means spin constant, the extension is same. So extension is equal to let x. Then weight of the block is equal to mg. So in K1 also x will happen, K2 also x will happen. So K effective is equal to, we will get K1 plus K2. Similarly, in this case also same problem. Now coming into series. So in series, right, in series, so K1, K2, two springs are connected like this. This combination of the springs connection is called series connection. And mg is suspended at K2. So now the mg is equal to K effective into x. So this total spring considered as 1K, one spring. This total spring considered as one spring, like a tension set. So now the x is equal to here x1 plus x2 will come. And now separately you take springs. The x1 is the extension in spring 1 and x2 is the extension in spring 2 when m is suspended. And here the extension how much taken place in K1 x1 means in the spring 1, extension in the spring 2 also equal here, K2 into x2. means x2 and x1 is not equal. So here you have to understand this. The force applied on a spring on spring 2 by spring 1 and on spring 1 by spring 2 is equal, like normal force here. If anyone is equal, anyone is not equal, then there is a chances to break. So the force acting on spring 1 by K2 or spring 2 on spring 2 by spring 1 is equal. K1 x1 equal to K2 x2. This is the forces on spring 1 by spring 2 by spring 2. So like this one model I will explain afterwards. This will be very important. And you know K2 x2 is equal to mg. Similarly K1 x1 is also mg. So you will get x1 x2 substitute means you will get K effective is equal to K1 K2 by K1 plus K2. The same thing will apply in simple harmonic motion also. Coming into cases, K1 both the springs are equal, K1 equal to K2. So that implies K effective is equal to K by 2. And there are n number of Ks are there. In the series K value is decreases, in parallel K value increases. In series Kx is equal to decreases that equal to K by n. All are equal, and in parallel K value is equal to Nk. So like same as resistors in parallel and the resistors in series, opposite here. Resistance in parallel means R by N equal resistance. Resistors in series means Nr, but here it is opposite spring constants. So you can understand. And we know the spring constant K value depends on the length and it is proportional to length from the Young modulus concept. So therefore the length is L dash is equal to L by 2. Then stiffness is equal to the stiffness of K dash is equal to, it will become 2K. K proportional to L. That's why K dash will become 2K. Mean the spring constant depends on factors. The spring constant depends on factors. First one is nature of the material. So with which material the spring is made. The second point is number of turns. Number of turns. And third one is length. Length of the spring. Length of spring. Not length of string. The length of string means n into 2 pi r's. N coils are there means n into 2 pi r's. Length of the spring. In this length of the spring. So here to here length of the spring in these 2 points. So there will be n turns will be there. Each turn is 2 pi r length. So now the length of the string is equal to n into 2 pi r. N strings are there means. The length of the spring is equal to n this n each thickness of the each coil into n. That is, so the difference in solenoid it will be very useful. A solenoid concept, this concept is useful. One or two models are there on this also. So now this is about the string, spring, series connection, parallel connection. And whereas let's see. So here the mass is suspended with the help of string in three different cases like this here. So on this some problems I'll give later. Means two more models are there, but I have not taken. Only three models I have taken. The concept in all the models is same, and no doubt at all. The concept means here. So asking in all these three arrangements, what is the maximum extension of the spring? Maximum extension taken place in the string. Whenever they are asking maximum extension, you have to equate the work done by work done. So here decreasing potential energy mg into x means the block is moving how much distance down. If the block is moving the x distance down, x displacement, the string also extends the same. The string also extends the same. But compared to the length released, it will be different. So now extra mass of the spring means displacement of the string as well as displacement of the block is same. Therefore, mg into xm equal to half kx square. Then we will get maximum extension equal to 2mg by k. So whereas coming into here, in this case, the spring is connected here. Now this pulley is mobile. So here pulley is not mobile. If the pulley is moving in the sense, the extension will become here. That extension will become when in the mobile case. So AD plus BC will come. But here it is not. This pulley is not mobile. Therefore, here mg is how much is moving down. The AD length also moves the same thing down. So AD is constant here. It will not means the string will not extend. Only spring will extend. So I hope here you got clarity why the extension in the mass and the extension in the string are equal in this case. Here pulley is not movable and the string is not extensible. Therefore, AD and BC will not change here. AD and BC will not change. No change. So therefore, how much mass is trying to move down, the same displacement taken place in the spring also. That's why this is the answer. Now coming into here, so mass is moving down here, x distance. The string is inextensible, therefore pulley moves down the same x distance. Pulley is moving xp distance, consider xp. This xp distance is equal to x of the string. So pulley is how much displacing down, the string also displaces the same amount. This I have discussed in NLM. NLM free body means their constraints equation. There I explained very clearly. You can verify that video also. Here pulley is how much displacing down. The extension in the string also same place, spring. But the displacement of the block is different. So now see, the spring is means the pulley is coming here. The AC and BD both will released. So BD length is released towards AC. Therefore, extension of the means motion of the block x maxima is equal to AC plus BD. I have written here small letters AC plus BD. The displacement of the block is equal to AC plus BD. So because the pulley is coming here, BD also releases towards AC side. AC is releasing and BD also releasing. Therefore, AC plus BD is releases downwards. So here AC or BD is extension of the spring or motion of the pulley. So that is equal to XP is equal to motion of the pulley is equal to XM by 2 from shortcut method. Otherwise, XP is equal to AC. Therefore, XM is equal to AC plus AD. That equal to 2 XP is equal to XM. Then XP is equal to XM by 2. Whatever. We can take shortcut method. What I have given in NLM concept. That we can take. Or here also I try to explain the same thing. Yes. So now, then after here 4 mg by k. So work done is are equal of kx square. So whereas come to here. So here how much displacement of the block is moving. The same extension in the means the BC is the displacement. The AD that extension. These two are equal point displacement data. So now the M is moving downwards with the displacement x. The same displacement should extend given by expanding the spring. Otherwise, the string is inextensible. It will not move. Here, the pulley is again fixed here, not movable. The movable pulley and fixed pulley, the springs are different case I have taken. Therefore, in equilibrium, mg is equal to kx we studied. The maximum extension, then we will go with kinetic energy is equal to potential energy. Mg into f is equal to kinetic energy. You will get 2 mg by k into m. This is the extension, maximum extension in the string. So now next problem, next model of the problem. So this is application of projectile kinematics as well as work power energy they are asking. So here string is compressed initially. That means it has potential energy kx square of kx square. Now we are cutting this string. That potential energy converting into kinetic energy and getting the velocity v. The block is the mass m is getting velocity. So mass is given 100 grams and 0.1 kg. By seeing the diagram, we can understand they are asking x equal to how much. And the horizontal height means this horizontal from the ground in the height 2 meters. Therefore, kinematics we know x is equal to v into t. The t value root over 2h by g, root over 4 by g. G value 10 you take for easy purpose. We not mention how much you have to take g, but take g only in work power energy and all. So now v square. To find out the v value, x equal to we know v into t, x equal to v into t, t is equal to I got 4 by 10 that equal to root over 0.4. Now v I want to find out kinetic energy is equal to potential energy. Apply means according to conservation of energy you get x equal to 1 meter. So coming into next question. So here the block is initially moving and see here some the logic points also mentioned here. It is very important and neat also. So initially it is at A and spring up to D. Now the block is moving with initial velocity, so initial kinetic energy is there. And before colliding here, the velocity is reduces because from B to D there is a friction, roughness. A to B it moves constantly. There is no work done on it, no external force also. Therefore moves constantly. From B to D, D to the friction, the velocity is decreases. So find out before going to hit how much velocity they having. So that is velocity at B and velocity at D. The velocity at B is equal to 3 meters second. What's in that note? So velocity at D we want to find out. So now the change in kinetic energy between B to D. So change in kinetic energy is equal to work done by the friction. So I want to find out the velocity at D and B is equal to 9. So if you substitute, then D value will get VD value. Now here it has velocity VD and from here this rough B to C rough surface only. D to D they have given 0.22 and D to C they have given 0.2 the roughness. So again here work done means decreasing kinetic energy is equal to increasing potential energy in the spring. Increasing energy is equal to decreasing energy. Therefore kinetic energy and friction energy are decreasing. which is converting into potential energy according to conservation of energy and work energy theorem also. By solving these two equations, you will get x is equal means v mg into x up to these values and half mv square vb is equal to 3 already I said, because a to b no friction, and all these values from these two 1 and 2 equations, 1 subtracting from 2 or 2 is subtracting from 1. So you got x equal to finally means quadratic equation is coming. From that x value is equal to 0.11 is coming, means compression in the string is equal to 0.1. So now all the distance is how much means a to b, b to d plus d to some distance compression that equal to x. So adding means you get answer. So in the same model, the same process, the same category, this question is different. So here what I have discussed is, see this. So initially the block is compressed from L1. Now releasing this force, now the block is kx force is applying, now compressed and releasing, L1 is compressed. Therefore F is equal to KL1 equilibrium. So now we are releasing means the mass is go to the double the length, double the compression, that equal to L1, and coefficient of friction between the surface and block is 0, frictionless smooth surface. Therefore 1 by 2 KL2 square equal to the force work done, 1 by 2 KL2 square is equal to potential energy, which is equal to work done by the applied force, that equal to F into L2. Already we know F equal to KL1, therefore L2 is equal to KK get cancelled to L1. It is very simple. So you understand. Initially by applying the force we compress to L1 distance, means L1 is the compression in the spring. Now we are releasing this KL1 because of this compression, it is giving the force on block to move to L2. That is the work done by the spring to move L2 distance to L1 or L2 distance. Okay, L2 is equal to L1 is coming, L2 distance is moving. So that equal to L1. Okay, how much distance will move after compression? So that is L2 I will take. So I will get 2 times of L1 is answer. Right. So next model of the problem. So like this is given inclined plane. So on the inclined plane, this is one model. And the spring here they are keeping and block is releasing. Here block is added to the spring. But in some models here down spring they will go and the block is coming and hitting the spring. That is another model. So it will come under. So maximum in all these cases, not only in this case, the work energy related cases by spring or by any remaining general case also, work energy theorem or conservation of energy or increasing energy is equal to decreasing energy. Model to model, which we have to apply, which one is easy that you take. So increasing energy is equal to kinetic energy or change in potential energy is equal to kinetic energy. This method will apply when a spring is suspending from the table of some length, L by n length, L by 3 length, 2L by 3 length. There, the total string is coming down. How much work done by the friction or what the velocity, total length is coming from the table. So in that cases, we lose increasing energy is equal to decreasing energy or work done by all the forces or change in kinetic energy is equal to change in potential energy. This any one method you can apply. So which is easier regarding to problem. By reading the problem, you have to understand which is easier. That's so that is by practice only will come. By listening the by reading the different books or different model of the problems, and by listening different orient means different classes by different persons. Okay, because I am very good in explaining this model of the problems. But some other models also there, some other cases also there. I am unable to take them. So maximum in all the cases, whatever the model, there will be one process in physics. That process you apply means you will get. But to apply the process handles, practice is main important. Okay, anyhow, come to this. Generally, I am because of my lot of experience, I am trying to motivating. This is a way I used to motivate the students in the classes. So it is coming. Sorry, it is online class. Right now. So in this case, same. And kinetic energy of the block is equal to kx square. Everything is given here. Then v is equal to, we will get from this x. Here x I want to find out. So to find out x, equilibrium conditions you will take. So already this is the maximum extension. So of kx square. So to find out from the free body diagram maximum extension. So next I will apply the free body diagram for 2 kg. So you will get like this x value, that is substitute now. Sin theta given sin theta value, cos theta value, so you will get answer is 0.312, 0.3162 meter seconds. This is the answer. So next model, here see. So one block of mass m is coming with velocity, and here velocity is reduced to 25%. Is now present it has the velocity is reduced to 25%. Then what is the maximum compression in this case? So same from the here, work done by conservative force means swing force. Remaining forces, friction is not there. Friction is not mentioned here. Not mentioned. Kinetic energy is reduced. So that may be by the friction or some brake applied something. So therefore, work done by conservative force is equal to change in kinetic energy. If you apply that method, we will get answer here. So next model C and continuation model above one. Sorry. You see in this case, the block is coming and hitting the screen. Same process, but here work done by mg also have to consider. Change in kinetic energy is equal to work done by conservative force. Therefore, change in kinetic energy work done by all the forces is equal to change in kinetic energy according to work energy theory. Change in kinetic energy is equal to work done by conservative force, swing force, and work done by non-conservative force. So here work done by non-conservative force means friction is equal to mg sin theta, means this side here theta is given here, therefore mg cos theta into x. Friction equal to mu mg sin theta, that is mu mg sin theta or mu mg and mu into n is maximum static friction. Okay, static friction is equal to on the inclined plane with inclination theta, static friction is equal to mg sin theta is always, remember this point, very very important, static friction. So it is ready to move, that equal to mg sin theta, f equal to mg sin theta, f equal to mu n, that is maximum static friction, n equal to mg cos theta, and theta is given down of the incline, but here it is given here theta, therefore sin theta will become as cos theta, mg cos theta into x, the gravitational force. So friction is not given, work done by non-conservative force will become 0. If friction is given means minus of you have to take, that is, so not given, so this will be 0. So work done by conservative force is of kx square spring force and mg into cos x. Or else you can apply decreasing kinetic energy is equal to increasing potential energy as well as mg cos theta into x. So these two energies, kinetic energy is increasing means the kinetic energy of this block now changing into spring potential energy and mg cos theta. Decreasing kinetic energy is changing into potential energy in the spring and mg cos theta into x. Now if you apply, you will get. So up to that only physics, remaining and all calculations substitution. So automatically we will get. And now this is very important. V equal to root 3 k by m into x, and x is equal to mg cos theta by k. Let's see this model of the problem. See, so this is not belongs to spring problem, but this conservation of energy, related to conservation of energy. So like these models I will discuss later also, number of models. Only today in this class, only spring I am going to take. Spring work done by spring force. So now this is the track, semicircular track. This one have acceleration g in the direction. So now this is moving downwards. Then acceleration on this it will be like, means force mg or horizontal force on this block is equal to opposite direction, pseudo force. So now is asking the work done. Velocity is given 2 power a by b into root gr. So a plus b they are asking. A plus b is equal to how much? So now here there is no other point under. So directly you can take this value also, or here to here also you can take, no problem. I have solved by using this. Otherwise directly you can use this one. This is some h. Initially it has potential energy mgr. Now it is mgh. So therefore we can go with change in potential energy is equal to kinetic energy. Change in potential energy is equal to kinetic energy. So here mg into r sin 45 will come here, sin theta is equal to half mv. So here h is equal to r into 1 minus cos theta we can write. Otherwise directly here h is equal to, so if it is theta, we can substitute h is equal to r sin theta. So by solving we get answer. So only the physics concept is change in potential energy, that is work done by conservative force, and here work done by external force mg r sin theta will be added extra. That will get half mv square kinetic energy, change in kinetic energy. So now from this solvation v equal to 2 power 3 by 4 is coming. So 3 plus 4 equal to 7. That is answer. Now in this problem, there is a spring initially. One end of the spring is a chain connected at the topmost point, and length of this string chain is less than r is greater than length. So up to here it is suspended. So now what is the minimum length, or when it is coming down, what is the velocity? So those type of questions going to ask here. And now what is normal acceleration, tangential acceleration? They are asking in a different case. See, first case. So the change in potential energy is equal to here. Potential energy is equal to dm into gh. For small element I have taken dm element. Its length dl will become dl equal to r into d theta. Dm is equal to m by l into r dl, that equal to r d theta into gh. So directly we will substitute remaining values under h is equal to r. Here is given theta, therefore 90 minus theta is equal to r cos theta. So if h is here now, if h I have taken this h means there will be r into 1 minus cos theta, but directly this h from the ground to this dm mass is equal to r cos theta into d theta again. So now integrating we will get mg r square by l into sine of l by r. Cos theta integration means sine theta will come. And here if you see the dl limits 0 to l by r means theta 0 to theta, that equal to theta means this one initial. The total is theta. So L by theta equal 0 to theta, that equal to L by R. Theta place L by R. So now the chain is further moving. Further angle theta is moved. So in the down diagram I have given in the down. So theta is moved further angle. Initially dm is here. So now it is moved further angle theta. Then what is the potential energy initially? Then after we will find out from the velocity, we can by finding the velocity we can find out the normal acceleration. The derivative will get tangential acceleration. So now I hope you understand here theta. So now limits are, so dm element limits, see this dm element theta to this length. So here this length is equal to theta, and this side is equal to L, means total length is equal to L by R plus theta. So this is only L. Because of further angle theta, the limits are changed to theta to L by R plus theta. This is important. So then we'll apply the same method. According to conservation of energy, increasing kinetic energy is equal to kinetic energy, decreasing potential energy. Or conservation of energy, work done by the conservative force is equal to change in potential energy, that equal to kinetic energy will apply. The kinetic energy of the spring is equal to, so change in potential energy dmg into h1 minus h2. So now h1 initial h1, that equal to r cos theta 1, means theta 1 initial value. Now theta 2 is further angle r cos theta 2. So now cos theta 1 is from 0 to L by R initial one. Initially we have taken right now. Now it is further theta means theta to L by R plus theta. You apply, you will get this answer. So only I am trying to explain the concept. Then after automatically solvation, if you know that concept means you will get it. Now the kinetic energy is equal to this much. V square is equal to, you are getting this value. So now V square by R is equal to, it is called V square by R is called centripetal acceleration or normal acceleration. So 2gr by L into sine of L by R minus sine theta, sine of L by R, r theta plus L by R plus sine theta will come on the limits from the integration method. So now next asking tangential acceleration. So in tangential acceleration, at is equal to, dv by dt. At is equal to dv by dt. So the dv by dt I will take as, v into dv by d theta I can take here. At is equal to, I can take v by r into dv by d theta. Actually v into at is equal to, v into means r alpha I can take d omega by dt. At is equal to r alpha, that equal to r into alpha is equal to d omega by dt. So again omega is equal to, I can add v by r. So this is equal to, so directly at is equal to alpha, okay, d omega by dr, that equal to, I can write v by r into dv by d theta. So this I can write. So v by r into dv by d theta. At is equal. Otherwise, instead of r alpha, it is not clear means you can go with at is equal to dv by dt. So that equal to v into dv by dx. So x is equal to, or length is equal to r into theta. So that equal to v by r into dv by theta. dl is equal to, means L is equal to r into theta, then dl is equal to dx equal to r into d theta. So therefore d theta equal to dl by r. So dl equal to r into d theta, that I can write v by r into dv by d theta. So now here v by r, so this total I will take in the bracket, I will take as x. From this V is equal to 2gr square into L by x will come. Now I am derivating this dV by x with respect to theta. I will get some answer. Here x value I have taken. So after derivating, root x is equal to 2gr by L is constant. The root x is equal to derivation of root x is equal to 1 by 2 root x into 1 by 2 root x. But here x is in terms of theta, therefore that again I have to do. So sin L by R 0 will become sin of L by R plus theta will be cos of L by R plus theta. Okay. Again d theta I am doing means L by R plus d theta I am doing means 1 only will come, no doubt. Sin theta will become cos theta. So now substituting all the values will get answer. Coming into next model, this model. So you can see here. So initially this is the system is given, small m and capital M. Now capital M has to move how much compression after compressing the m downwards. So I am compressing to x1 displacement, small m. Compressing and releasing now. Then this m2 is leaving the contact. Then they are asking x1 should be how much? How much I have to compress the first block to lift the m from the surface. Sorry, this is something troubling. So now there conservation of energy method again. All these are conservation of energy only. If you apply here, you will get answer. The work done by the small block is small block to compress x1 plus x2 is equal to change in kinetic potential energy of the spring of k x2 square minus x2 is when m2 is rising. Means m1 block is compressed to x1 distance and it is jumping to x2. So that is. So now solving this equation, we will get x1 equal to 3 mg by k. So next model of the problem. So here see, mass is given 4 kg and friction between the m1 and the surface is given 0.5. m2 is released from the rest now. The value of m2 to move m1 is asked. So when spring is not there, NLM you apply means you will get. But spring in the place of tension, the kx will come here. So kx is equal to minus mu1 into mg. Kx is opposite to the motion of the block. Therefore, minus will come here. Minus minus get cancelled. Therefore, mu1 into mg, mu into m1g is equal to frictional force equal to kx. So this is the equation 1. And now m2 is released. So how much distance m2 is moving? The same extension will take place in the spring. So extension in the spring is equal to work done by m2g. Therefore, m2g into x displacement of m2 is use the displacement in the spring x. Therefore, kinetic energy in the spring is equal to mgx. X value will find out here. That is substitute now. You will get answer 1 kg. So here this is a simple application. K1, K2, K3 all are parallel. So sum we will do K1, K2 parallel and K3 also parallel. So total K1, K2, K3 values also given. Substituting means you will get answer. And now this model, see here 2 models I have taken. So here spring is one end is fixed here, and the another end is there is a one ring of mass m. Now release after stretching, now we are releasing. So now this is x naught 2 plus x naught 2 centimeter 2 meter is the natural length. 2 meters is the natural length of the spring. Natural length of the spring is equal to 2 meters. So now it is stretched and kept here at this point. Now released. So after releasing, it is coming vertically. It is coming to here. This side. That means the compression in the spring is equal. I have to find out. That is x naught in the compression. I have taken x naught in the compression. So 2 by 2 plus x naught. That means cos theta. 2 by adjacent by 2 plus x naught is equal to cos 37 4 by 5. So x naught value I will get. Now that is simple. Next energy conservation of energy. Half mv square equal to k square. The velocity of the block is equal to 500 centimeter second inverse 5 meter second inverse. So already this case came. So now for this one here, mg, the work done by spring force is means you can ask here what about the mg work done by the mg force, what happens means mg and displacement of the block is equal to perpendicular. So work done by mg is 0. But coming into here, this ring is sliding on this slider on the support, and natural length of the spring is equal to 4 meters. Natural length. Four meters. So now when this is coming to here, that means 3 meters displacement is happened along the mg direction. So therefore here mg x you have to take, mg h you have to take, and the spring energy means it is a 5 and 4. So displacement equal to 1 will come. Here compression is equal to maximum compression equal to 1 meter will come. So now substituting, the decreasing potential energy is equal to increasing kinetic energy. Therefore half mv square is increasing. MGH is decreasing from here. It has MGH initially decreasing, therefore MGH is decreasing, and half kx square also decreasing. It is coming to natural length from maximum extension. So these are equate, means you will get answer. And conservation of work done by conservative force is equal to change in kinetic energy here. So change in potential energy is equal to kinetic energy. Yes. Not work done by conservative force equal to change in kinetic energy. Change in potential energy is equal to kinetic energy of every square. So you will get answer 10 meters second. Coming into next model. So these two models are same concept, but the point is here angles are given in this example, here distance are given. And generally when initial stage will start doing the problems like this. So the black is here at a 3.3 meters initially and coming to 4.4 meters. So this is the distance displacement will consider. So this is rank. So 3.3 3 root 3 minus 4 is displacement will consider. This is rank because so this is the displacement of black, but along the force direction the releasing length by the string is you have to find out. That is causes the work done. This x we have to find. So this the releasing in the string, how much length is released, that is displacement by this force. So that will be calculated from L2 L1 minus L2 or L2 minus L1 L1 minus L2. So L1 and L2 are hypotenuse. So from the given values, you'll find out the hypotenuse here 4 root 3 and 3 root 3 and 3. Therefore 6 5 will come. Substitute means answer will come. Similarly here also 30 37 is given. Hypotenuse values L1 and L2 will find out. So L1 minus L2 is the displacement. So that is substitute means you'll get answer. And here not only one question, only work done is not asking. Work done by the applied force is not asking. And here work done by gravity is 0. So gravity and the displacement of the black or trolley is perpendicular. So velocity of the trolley is asking. For half mv square is equal to work done. V square equal to this. Ratio of acceleration. So that equal F by M. So F cos theta by M means horizontal only motion is there. Therefore F cos theta horizontal component on this black. So this is F means or T into cos 30 by M into M by T cos 37. T you can take. So that force. So 5 root 3 by 8 will get answer. So last two models. So in this model, same this one is studied, but here so initially the black M is on the ground, frictionless ground. Now what is the mass of small m to lift the M, capital M? What is the minimum mass of M to lift this M? So now similarly in the first case we studied how much displacement done by the black means this A black, the same extension will come in spin. So due to this extension the force will be developed on M, that equal to Kx is equal to mg. Here K into x is equal to capital M into G. And from the work done equation maximum extension K into x equal to mg also coming. Therefore 2 small mg is equal to mg, M equal to m by. Similarly this problem also, but here these two blocks are suspended with different k values. So this spring will extend differently x1 displacement and this spring will extend x2. Both are not same displacement will be done. But the black of m1 and m2, the displacements equal to the x1 and x2. The springs are not there means displacement of m2 and displacement of m1 are same because gyrations are same. But here displacement of m1 and displacement of m2 are different because of the spring constants. So now acceleration m1 is greater than m2 constant means acceleration is equal to m1 minus net force by total mass, that you will get. And applying the free body diagram for m2 and m1 and substitute the a value, you will get the different extension in x2 and x1. So that equal to x2 equal to m1 m2 g by m1 plus m2 into k2 and x1 equal to 2 m1 m2 g by m1 plus m2 into k1. These are the extensions in x1 and means spring 1 and spring 2, and those two are different. So this is the model of problems on spring. There are some other problems also. I think I feel them as somewhat easy. So I have chosen these problems to solve. So there are some more other problems also there. So people can try in reference books. So thank you.